Okay, going to go through some examples from Worksheet 6, which is about graphs, but it's also building on things we've talked about with units and dimensions, and there's a bit of unit conversion on there too. I'm not going to go through question 1. I think that's reasonably straightforward, and you can find the answers to that on the answer sheet. But let's have a look at question 2. In here, I'm asking you to think about what a graph might look like between certain pairs of variables, and then what the gradient of a line would be, what it would mean. So let's have a look at so 2a. I tell you to think about time against distance. And this is quite unusual, so we might have time against distance this way. Normally you'd expect to see time along the x direction and maybe distance up this way. So this is a different way of plotting it. We can imagine a straight line going through it like that. And remember, the gradient of this line is the change in y over the change in x. So the change in time divided by the change in distance. So if we give these some sensible units, let's say time is in seconds, and then distance would do in meters. So the units of the gradient would be seconds divided by meters, or s divided by m. Let's put our square brackets around here to remind ourselves that these are units. So s over m in our standard notation. So seconds per meter. Normally, if we think about speed, that would be meters per second. That would be as if the graph were flipped around the other way. But seconds per meter is maybe a bit unusual, but we can think about what that actually means, and that's the amount of time it would take to go a specified distance. So if the gradient of this line was 2 seconds per meter, that would tell you to go across 1 meter, it would take you 2 seconds. Okay, or you could think the other way of doing that is to flip that the other way up. So let's say 2 seconds per meter is the same as half a meter per second, which makes sense, right? Okay, and then let's just quickly think about question 2b along similar lines. I'm not going to go through the many more of question 2. So here I ask you about time, and then this time velocity. I'll write that out. And what would the gradient of that line be? Well, velocity, let's give it units of meters per second. We'll write that m per s, and then therefore we do time in seconds. Gradient of that line is going to be meters per second divided by seconds. So let's think how we could do that. So one way we could say that's meters per second divided by seconds, and we can, if you remember about our replacing a divide by a multiply, so that could be therefore meters per second times 1 over seconds. So dividing by seconds is the same as multiplying by 1 over seconds. Dividing by 2 is the same as multiplying by half, etc. So that would then give us meters per second squared. Okay, or meters m to the minus 2. And this is the units of acceleration. So with this line, this has got a positive gradient, so this would say that the speed is getting faster with time, so we're accelerating. If the line went down this way, that would be decelerating. Okay, so in question 3, it's again more about manipulating units and thinking about dimensions. Then I tell you in this question that we're going to measure mass, so let's work in our dimensions, m, l, and t, mass, length, and time. Mass is in pounds, so kind of an old-fashioned unit, and that's given the symbol lb, coming from the Latin. Length is in feet, and we give that the abbreviation ft, and then time is in years, and we give that the abbreviation yr in this case. So throughout there, I ask you to define various quantities using these units. We'll just do a handful here. So the first one I talk about is volume. So volume is length cubed. Okay, it's length times length times length. So here the units of volume would be feet cubed. Okay, so in our units, the way we've defined the dimension of length has a unit of feet here, so that will be feet cubed. Velocity, which I believe is the second one, I asked you about, so that's it. So v, it's a common symbol we use for velocity. Velocity has units of length divided by time, or L t to the minus 1. So therefore, in this, that would have units of feet per year, and let's write it that way. So we could write that as feet divided by year, or feet per year, like that. Acceleration is the third one I asked you about. So let's give that the symbol A. That's velocity divided by time, and we did this on the just for question 2. That's length per time squared. So here, feet per year squared. Let's just do a couple more here. So one of the other ones I asked you about, I think it's D, which is force. So force, and you'll see this in the notes, and this is also Newton's second law. Force is mass times acceleration. So if we take acceleration from what we've got here, so let's just do that in our dimensions. So it's mass mL t to the minus 2. That's our dimensions of force. Okay, so therefore the units of that are going to be mass is in pounds, length in feet, and then time to the minus 2. So the units of force here will be pounds feet per year squared. Okay, there are more manipulations that you can do there. I asked you about converting from like force into energy, and going to pressure, and also to power. If you go through and have a look at the other video where I introduced this whole section, or the one on the units of dimension, sorry, you'll get some idea about how to do that. But I'm happy to address that separately. Okay, finally, question 4 is another unit conversion one, and I think it is worth going through these because they're often ones that people can struggle with. So here I'm asking you to convert 34 furlongs. Furlongs is a distance often referred to in horse racing. Furlongs per second into miles per hour. Okay, and I tell you that 1 furlong equals 200 meters, and that 1 mile equals 1600 meters. Okay, so if we just give these unit conversions units, so that's saying there are 200 meters per furlong, and here that is 1600 meters per mile. Okay, that makes sense. Now the other thing we've got to do, so these, and we'll worry about how we're going to do that exactly in a minute. This is going to get us from furlongs to meters, and then we're going to go meters to miles. But the other thing we have to do is go from time in seconds to time in hours. So we can do that ourselves. I didn't give you that unit conversion, but I think we can just do that just from knowledge that we have. So we know in an hour, 1 hour equals 60 times 60 seconds. There are 60 seconds in a minute and 60 minutes in an hour. So 60 times 60 seconds, which equals 3,600 seconds. So we can say that there are 3,600 seconds per hour. Okay, let's have a look at this conversion now. What's the equation that we're going to do? So we've got 34 furlongs per second. Just give that an S. Let's think about multiplying. Let's deal with the time, because that's easy. So seconds per hour. This is already in the right units, the right way around for us, because it's got seconds on top and hours underneath. So therefore the seconds up here will cancel out with the seconds down here. So let's multiply that. 3,600 seconds per hour. Okay, what about length? We need to now go from furlongs to meters. This is good. So meters per furlong. Our furlong is underneath. Here we've got furlong on top, so those are going to cancel out. So this is already the right way around for us. So times 200 furlongs per meter. Okay, so we can see meters per furlong. I keep these in just so you know that I do make mistakes as well. So 200 meters per furlong. You can see the furlong is going to cancel out here. Now we're left with the last one. We need to now go from meters. So this is going to give us meters. So furlongs are going to cancel out and give us meters. We're going to need to go from meters to miles. Now this is the wrong way around for us, because this is already meters per mile. So we need the meters underneath and the miles on top, because that's where That's where we want to end up with. So we're going to have to invert this. So rather than it being 1600, it's going to be 1 over 1600 miles per meter. We just think about some of these conversion units. They hopefully make sense. 3,600 seconds in an hour. 1 over 1600 miles in a meter. So 1 meter is 1/1600th of a mile. That's the way of saying it. Okay, so furlongs cancel out with furlongs, seconds cancel out with seconds, and meters cancel out with meters, and we're just left with miles per hour. So we know that when we go through and do this sum, we're going to end up with the right units. So let's write that out down here. So 34 times 3,600 times 200 times 1 over 600, which is the same as saying dividing by 600. And that's going to have units of miles per hour. And if you were to put that in to your calculator, you're going to end up with 15,300 miles per hour, which is very, very fast, as you probably can work out. In fact, it's about 20 times the speed of sound. Okay, so I hope that was helpful for you. Just another unit conversion example, and we've seen about, again, thinking about maths in terms of the words they are with some of the earlier questions. Good luck.